Okay, let's talk about carbohydrates as far as one of our major macromolecules here. So we can think of carbohydrates as a quick energy source. And let's kind of think about that a little bit, put that on the shelf, and then talk about it a little bit more. So when we think of carbohydrates, we tend to think of bread, pasta, but don't forget that we also have fiber, right, which is also considered carbohydrate. So including that would be bananas, oranges. It looks like there's an apple right there. But before we jump into this, we've seen the recent concern with regards to gluten in carbohydrates. So I have a quick question for you guys. What is gluten? We tend to associate gluten with our carbohydrates, right? So we tend to think of gluten in our pasta, in our bread. So my question for you is gluten a carbohydrate? What do you guys think? So gluten is actually not a carbohydrate. Gluten is found in wheat and rye and barley. And so that's probably why we associate it with carbohydrates. But gluten is actually a protein. And it's a protein that functions to give structure and texture to bread products, to pizza dough. So you can tell that when you eat a piece of bread that is gluten-free versus not gluten-free, that there's a difference in texture, and that's because of that gluten. That gluten is a protein that kind of gives it that texture. And so why is it, if it's just protein, why is it that some people who consume it are allergic to it, right? So you have celiac disease, in which people can't easily consume gluten without having some intestinal issues. So why do you think that is? Yeah, so gluten is actually a protein, and that's typically how your body, like my body, I don't have celiac disease. So my body would just recognize gluten as a protein, and it'll break it down the way that we expect it to with regards to protein. But for people with celiac disease, they actually recognize gluten as a foreign, almost like a foreign pathogen. So because it's considered a foreign pathogen, the body will respond by inflammation. It will respond by, and with the inflammation comes damage to the intestinal lining. And so that's why these people who have celiac disease have a harder time digesting glutens, because it's not recognized as a simple protein product. It's actually recognized as a foreign product. Okay, so we're going to focus a little bit more on carbohydrates. Let's kind of talk about it a little bit more. So it's found plentiful in nature, right? We see it in a lot of plant matters that we consume. Everything from your lettuce and salad, to your oranges, to your bananas, to your strawberries, to your zucchinis. Those are all different type of carbohydrate. And we consume this because it's quick energy. Remember, previously we had talked about how all living organism needs to consume some kind of material energy product. So this, for us, carbohydrate is a quick way to use this energy source. Carbohydrate can also function as a structural component. So we'll talk about that in a little bit, what we mean by structural component. So carbohydrate is an organic molecule that consists of carbon, hydrogen, and oxygen. So we've already talked about how organic molecules have a carbon, hydrogen backbone. Additionally, carbohydrates, so all of these different components that we see here, bread, potato, rice, they also have oxygen. And their oxygen, these different atoms exist in a 1:2:1 ratio, meaning that for every 1 carbon, we have 2 hydrogen, and we have 1 oxygen. We also talk about how these organic molecules exist as monomers and polymers. So here, a monomer of carbohydrate is known as a monosaccharide. A polymer of carbohydrate is known as a polysaccharide. And so what that means here is we have one monomer of carbohydrate, whereas here we have many monomers of carbohydrate linked together. So if you have a disaccharide, you have 2 monomers. An oligosaccharide will have 3 to 10, and a polysaccharide will have greater than 10. So here is one monomer of carbohydrate, and this is actually glucose over here. So we actually have it as glucose. And glucose has a 1 1:1 ratio, right? You can kind of see here that for every 6 atoms of carbon, you have 2 times 6, so 12 atoms of hydrogen, and 1 times 6 atoms of oxygen. So that's what we mean by the 1:2:1 ratio. So let's take a closer look at glucose and fructose. So first, let's introduce simple versus complex carbohydrate. So a simple carbohydrate will have 3 to 7 carbons in its backbone. They tend to be sweet tasting, so we tend to know them as glucose and fructose, and both of those are very sweet tasting, and they're also water soluble. And our body is able to use glucose and fructose pretty readily, so they're a quick energy source for cells. So if the cells have a choice, they will tend to use glucose first as an energy source. And so over here, what we have is the structure of glucose and fructose. So if you recall before, we said that glucose is C6H12, right, and O2. So this molecule that we're looking right here, let me make it 12 here. This molecule of glucose that we're looking at right here has that ratio, right? So each one of these little branches or branching you see right here is actually a carbon. This is how we tend to draw carbon in these structures. Similarly, down here, this is the linear version of glucose, and each time that you see an intersection here, this is actually a carbon molecule right here. So I'll just draw a few for us to see. Okay, so let's go back to this one. So we can see that this is 1, 2, 3, 4, 5, 6. So it has 6 carbon. If we counted up the hydrogen, it would equal to 12 hydrogen. And if we count up the oxygen, it would equal to 6 oxygen. And here is this linear structure. So we're not getting rid or adding any atoms to it really. What we're doing is we're rearranging it. So this is actually the linear version. So over here where you saw a single bond between this carbon and this oxygen, down here we see it as a double bond. Okay, so you guys don't need to memorize these structures, but just kind of be aware of them. Fructose is also 6 carbon, but the structure is slightly different because you can see that the branching here has this HOCH2 structure, and same over here, but we still have 6 carbons. So if we actually count them out, we have 1, 2, 3, 4, 5, 6. And here is this linear structure. So these are both simple carbohydrates. So what do we mean by complex carbohydrate then? Well, complex carbohydrate will be a longer chain of monomers of carbohydrate. So it's a polysaccharide. We can observe these in 2 different forms. We can observe these in starches. So starch is how we actually store carbohydrates in plants, or how plants store carbohydrate. Whereas us as animals, we actually store carbohydrate as glycogen, and we store this in our liver. So when our body wants to actually, after you consume your carbohydrates and it still finds that it needs a carbohydrate source, it will go and it will grab the glycogen and break it down to into glucose. And then you have cellulose, which is also a version of complex carbohydrate, and it tends to be tough and indigestible structure of plants. So this is where we're talking about with regards to structure, right? So we talked about before how carbohydrate can play as a structural. So here we have structural, and for us as animals, we can't digest the cellulose the same way that we can digest like other carbohydrates. So I'm going back to the bread. It's easy for our body to break down that bread into glucose and actually consume it. But with cellulose, we're not able to break up that polysaccharide into monosaccharide that we can easily use, but it actually still plays an important role. And we'll talk about that a little bit more when we talk about soluble and insoluble fiber. And then lastly, another version of the structural carbohydrate is this chitin, and we can find these in crabs, lobster, insects, and this is actually the insect's exoskeleton. So that exoskeleton that we observe in insects is actually made of carbohydrates. And so here are some examples of what this would look like. So as I mentioned before, plants will store its carbohydrate as starch. So here we can see this is what the starches look like, whereas animals will store the carbohydrate polysaccharide as glycogen in this liver cell. And so they kind of have a similar, they're both kind of long chain. Sometimes they have slightly branched, right? You can kind of see a slightly branched. Sometimes the non-branched, so this one doesn't have like a branch here, like this branching is happening right there, right? So here we can see highly branched, and it's because we have a branching right here, we have a branching right here, we have another branching, I believe it's right here, and so on, right? So this is highly branched. So this is glycogen. This is how we store our carbohydrate in our body as an energy source. And so how about carbohydrates in our food? So we tend to think of carbohydrate, or at least when someone says carb, I'm not usually visualizing the organic molecules. I'm typically thinking what we know on a day-to-day basis as our food, right? So let's first look at high fructose corn syrup. So high fructose corn syrup is actually, so what happens is that in corn stores carbohydrates as glucose, right? So corn starch is actually made of glucose, but we can actually synthetically use an enzyme. So enzyme is a type of protein. We'll talk about that a little bit when we talk about proteins. But an enzyme is able to kind of catalyze the reaction. So it actually catalyzes converting glucose into fructose. And why do we do this? Well, fructose, actually high fructose corn syrup, actually is more stable. So with it being more stable, it actually can exist on our shelf for a lot longer. And it's actually more stable in different type of acidic food and drinks. So it has a longer shelf life. So that makes it a lot cheaper. So why is it that we tend to avoid high fructose corn syrup when we actually consume carbohydrates? Well, it's because high fructose corn syrup has been shown to be linked to heart disease, diabetes, fatty liver, and it actually is also associated with resulting in abnormal levels of cholesterol and fat in the blood. And a lot of times we see that fructose can also lead to accumulation of visceral fat. So this is the type of fat that is around your organ. We actually don't want this fat around our organ. It's actually can be dangerous. And so this is kind of one of the reasons why it's been suggested that you avoid high fructose corn syrup. Okay, let's move on to maltose. So what is maltose? Well, maltose is a carbohydrate, is a disaccharide, and it consists of two glucose. So here's one glucose, here's two glucose. They're linked together right here. And when we break down maltose, we can break it down to two glucose. Well, these two glucose can be actually fermented by yeast as an energy source that gets converted into ethanol and carbon dioxide, and that will result in it was in beer right here. So beer is actually a combination of ethanol and CO2, which is why it kind of has like that fizziness to it, is because as a byproduct of when yeast is fermenting it, it will also create carbon dioxide. And lastly, we want to look at insoluble versus soluble fiber. So fiber is actually really important for your gut health, and it's because we have these two fibers. So insoluble means it's not soluble, so it can't dissolve in water, where soluble fiber can dissolve in water. And so soluble fiber is found in carrots, psyllium, apple peas. And so when we mix the soluble fiber in water, it will actually form like this gel-like substance, and it kind of helps us slow down our digestion. So that also helps, it's also been linked to helping us control blood sugar and cholesterol. Insoluble fiber, our body actually doesn't break that. It doesn't dissolve. So because it doesn't dissolve, our body actually can't digest it. But it's actually still really good for us to consume insoluble fiber, because it kind of helps move food through our digestive system. So it kind of helps us with constipation, and it even while we can't use it as energy source, we can actually still use it as our roughish to kind of help with aid our digestive system. And so I have a question for you. So when we look at an orange, do we consider an orange a carbohydrate? And here's the nutritional panel for oranges. And also, do you think oranges have soluble or insoluble fiber? So we look at this right here and we can see that, we definitely do consider orange as a carbohydrate because of the main carbohydrate, protein, fat. You can see the carbohydrate is the one that oranges seems to have the most of, and it has a dietary fiber of 2.3 grams and a sugar fiber of 9. So this is where we're getting our energy source from, is this 9 grams of sugar. Additionally, we have this dietary fiber. So is this fiber insoluble or soluble, do you think? It's actually both. So we actually have both insoluble and soluble fiber. And so roughly there's more insoluble fiber in an orange than there is soluble fiber. The soluble fiber would be the pectin, and it's going to help, like we mentioned before, regulate our blood sugar level, our cholesterol level. So it's actually really good to eat an orange. But oranges also have a lot of like insoluble fiber. So that insoluble fiber, so that's why there's a difference between when we consume orange juice versus oranges, is that the benefit we get from consuming an orange is this insoluble fiber that we have in here, right? So the insoluble fiber, as we mentioned before, is going to help aid in our digestion. It's going to kind of bulk up our stool, and it's going to make it so that if you are constipated, go ahead and consume an orange, because an orange has a lot of that insoluble fiber to kind of help aid your digestion. Okay, so we'll stop here with carbohydrates. I hope that the next time that you consume a piece of bread or an orange or a banana or cherries or whatever it is that you choose to consume, that you kind of think a little bit more about the benefit of what this food that we're eating helps with regards to energy and fiber.